Security Assertion Markup Language.
Security Assertion Markup Language is an XML-based open standard data format for exchanging authentication and authorization data between parties, in particular, between an identity provider and a service provider. SAML is a product of the Oasis Security Services Technical Committee. SAML dates from 2001. The most recent update of SAML is from 2005. The single most important requirement that SAML addresses is web browser single sign-on, SSO. Single sign-on solutions are common at the intranet level, using cookies, for example, but extending these solutions beyond the intranet has been problematic and has led to the proliferation of non-interoperable proprietary technologies. Another more recent approach to addressing the browser SSO problem is the OpenID protocol. The SAML specification defines three roles: the principal, typically a user, the identity provider, IDP, and the service provider, SP. In the use case addressed by SAML, the principal requests a service from the service provider. The service provider requests and obtains an identity assertion from the identity provider. On the basis of this assertion, the service provider can make an access control decision. In other words, it can decide whether to perform some service for the connected principal. Before delivering the identity assertion to the SP, the IDP may request some information from the principal, such as a username and password, in order to authenticate the principal. SAML specifies the assertions between the three parties, in particular, the messages that assert identity that are passed from the IDP to the SP. In SAML, one identity provider may provide SAML assertions to many service providers. Similarly, one SP may rely on and trust assertions from many independent IDPs. SAML does not specify the method of authentication at the identity provider. It may use a username and password, or other form of authentication, including multi-factor authentication. A directory service, which allows users to log in with a username and password, is a typical source of authentication tokens, for example passwords, at an identity provider. The popular Internet social networking services also provide identity services that in theory could be used to support SAML exchanges.
History of SAML.
The Oasis Security Services Technical Committee, SSTC, which met for the first time in January 2001, was chartered to define an XML framework for exchanging authentication and authorization information. To this end, the following intellectual property was contributed to the SSTC during the first 2 months of that year. Security Services Markup Language, S2ML, from Nitigrity, XML from Securant, XML Trust Assertion Service Specification, XTAS, from VeriSign, Information Technology Markup Language, ITML, from Jamcracker. Building on this work, in November 2002 Oasis announced the Security Assertion Markup Language, SAML, v1.0 specification as an Oasis standard. Meanwhile, the Liberty Alliance, a large consortium of companies and non-profit and government organizations, proposed an extension to the SAML standard called the Liberty Identity Federation Framework, IDFF. Like its SAML predecessor, Liberty IDFF proposed a standardized, cross-domain, web-based, single sign-on framework. In addition, Liberty described a circle of trust, where each participating domain is trusted to accurately document the processes used to identify a user, the type of authentication system used, and any policies associated with the resulting authentication credentials. Other members of the Circle of Trust may examine these policies to determine whether to trust such information. While Liberty was developing IDFF, the SSTC began work on a minor upgrade to the SAML standard. The resulting SAML v1.1 specification, ratified by the SSTC in September 2003, was widely implemented and deployed, and is still in use today. Then, in the same month, Liberty contributed IDFF to Oasis, thereby sowing the seeds for the next major version of SAML. Thus in March 2005, SAML v2.0 was announced as an OASIS standard. SAML v2.0 represents the convergence of Liberty IDFF and other proprietary extensions, as well as early versions of SAML itself. Most SAML implementations now support v2.0 while many still support v1.1 for backward compatibility. Deployments of SAML v2.0 are common in government, higher education, and commercial enterprises worldwide.
Versions of SAML.
SAML has undergone one minor and one major revision since v1.0. SAML 1.0 was adopted as an OASIS standard in November 2002. SAML 1.1 was ratified as an OASIS standard in September 2003. SAML 2.0 became an OASIS standard in March 2005. The Liberty Alliance contributed its Identity Federation Framework, IDFF, to the OASIS SSTC in September 2003. IDFF 1.1 was released in April 2003. IDFF 1.2 was finalized in November 2003.
Differences between v1.1 and v1.0.
Versions 1.0 and 1.1 of SAML are similar even though small differences exist.
Differences between v2.0 and v1.1.
The differences between SAML 2.0 and SAML 1.1 are substantial. Although the two standards address the same use case, SAML 2.0 is incompatible, on the wire, with its predecessor.
Differences between v2.0 and IDFF 1.2.
Although IDFF 1.2 was contributed to OASIS as the basis of SAML 2.0, there are some important differences between SAML 2.0 and IDFF 1.2. In particular, the two specifications, despite their common roots, are incompatible, on the wire.
SAML building blocks.
SAML is built upon a number of existing standards.
The anatomy of SAML.
SAML defines XML-based assertions and protocols, bindings, and profiles. The term SAML core refers to the general syntax and semantics of SAML assertions as well as the protocol used to request and transmit those assertions from one system entity to another. SAML protocol refers to what is transmitted, not how. The latter is determined by the choice of binding. So SAML core defines bare SAML assertions along with SAML request and response elements. A SAML binding determines how SAML requests and responses map onto standard messaging or communications protocols. An important, synchronous, binding is the SAML SOAP binding. A SAML profile is a concrete manifestation of a defined use case using a particular combination of assertions, protocols and bindings.
SAML assertions.
A SAML assertion contains a packet of security information. Loosely speaking, a relying party interprets an assertion as follows. SAML assertions are usually transferred from identity providers to service providers. Assertions contain statements that service providers use to make access control decisions. Three types of statements are provided by SAML. Authentication statements, attribute statements, authorization decision statements. Authentication statements assert to the service provider that the principal did indeed authenticate with the identity provider at a particular time using a particular method of authentication. Other information about the authenticated principal, called the authentication context, may be disclosed in an authentication statement. An attribute statement asserts that a subject is associated with certain attributes. An attribute is simply a name-value pair. Relying parties use attributes to make access control decisions. An authorization decision statement asserts that a subject is permitted to perform action A on resource a given evidence E. The expressiveness of authorization decision statements in SAML is intentionally limited. More advanced use cases are encouraged to use XACML instead.
SAML protocols.
A SAML protocol describes how certain SAML elements, including assertions, are packaged within SAML request and response elements, and gives the processing rules that SAML entities must follow when producing or consuming these elements. For the most part, a SAML protocol is a simple request-response protocol. The most important type of SAML protocol request is called a query. A service provider makes a query directly to an identity provider over a secure back channel. Thus query messages are typically bound to SOAP. Corresponding to the three types of statements, there are three types of SAML queries: authentication query, attribute query, authorization decision query. Of these, the attribute query is perhaps most important, and still the object of much research. The result of an attribute query is a SAML response containing an assertion, which itself contains an attribute statement. See the SAML 2.0 topic for an example of attribute query response.
SAML 1.1 protocols.
Beyond queries, SAML 1.1 specifies no other protocols.
SAML 2.0 protocols.
SAML 2.0 expands the notion of protocol considerably. The following protocols are described in detail in SAML 2.0 core: Assertion query and request protocol, Authentication request protocol, Artifact resolution protocol, Name identifier management protocol, Single logout protocol, Name identifier mapping protocol. Most of these protocols are completely new in SAML 2.0.
SAML bindings.
A SAML binding is a mapping of a SAML protocol message onto standard messaging formats and/or communications protocols. For example, the SAML SOAP binding specifies how a SAML message is encapsulated in a SOAP envelope, which itself is bound to an HTTP message.
SAML 1.1 bindings.
SAML 1.1 specifies just one binding, the SAML SOAP binding. In addition to SOAP, implicit in SAML 1.1 web browser SSO are the precursors of the HTTP post binding, the HTTP redirect binding, and the HTTP artifact binding. These are not defined explicitly, however, and are only used in conjunction with SAML 1.1 web browser SSO. The notion of binding is not fully developed until SAML 2.0.
SAML 2.0 bindings.
SAML 2.0 completely separates the binding concept from the underlying profile. In fact, there is a brand new binding specification in SAML 2.0 that defines the following standalone bindings. SAML SOAP binding, based on SOAP 1.1, reverse SOAP, PAOS, binding, HTTP redirect, GET, binding, HTTP post binding, HTTP artifact binding, SAML URI binding. This reorganization provides tremendous flexibility. Taking just web browser SSO alone as an example, a service provider can choose from 4 bindings: HTTP redirect, HTTP post and 2 flavors of HTTP artifact, while the identity provider has 3 binding options: HTTP post plus 2 forms of HTTP artifact, for a total of 12 possible deployments of the SAML 2.0 web browser SSO profile.
SAML profiles.
A SAML profile describes in detail how SAML assertions, protocols, and bindings combine to support a defined use case. The most important SAML profile is the web browser SSO profile.
SAML 1.1 profiles.
SAML 1.1 specifies 2 forms of web browser SSO, the browser artifact profile and the browser post profile. The latter passes assertions by value whereas browser artifact passes assertions by reference. As a consequence, browser artifact requires a back-channel SAML exchange over SOAP. In SAML 1.1, all flows begin with a request at the identity provider for simplicity. Proprietary extensions to the basic IDP-initiated flow have been proposed, by Shibboleth, for example.
SAML 2.0 Profiles.
The web browser SSO profile has been completely refactored for SAML 2.0. Conceptually, SAML 1.1 browser artifact and browser post are special cases of SAML 2.0 web browser SSO. The latter is considerably more flexible than its SAML 1.1 counterpart due to the new plug-and-play binding design of v2. Unlike previous versions, SAML 2.0 browser flows begin with a request at the service provider. This provides greater flexibility, but SP-initiated flows naturally give rise to the so-called identity provider discovery problem, the focus of much research today. In addition to web browser SSO, SAML 2.0 introduces numerous new profiles. SSO profiles. Web browser SSO profile, enhanced client or proxy, ECP, profile, identity provider discovery profile, single logout profile, name identifier management profile, web browser SSO profile, enhanced client or proxy, ECP, profile, identity provider discovery profile, single logout profile, name identifier management profile, artifact resolution profile, assertion query request profile, name identifier mapping profile, SAML attribute profiles. A number of these profiles are discussed in more detail in the SAML 2.0 topic.
The SAML use case.
The primary SAML use case is called Web Browser Single Sign-On, SSO. A user wielding a user agent, usually a web browser, requests a web resource protected by a SAML service provider. The service provider, wishing to know the identity of the requesting user, issues an authentication request to a SAML identity provider through the user agent. The resulting protocol flow is depicted in the following diagram. 1. Request the target resource at the SP, SAML 2.0 only. The principal, via an HTTP user agent, requests a target resource at the service provider. The service provider performs a security check on behalf of the target resource. If a valid security context at the service provider already exists, skip steps 2 to 7. 2. Redirect to the SSO service at the IDP, SAML 2.0 only. The service provider determines the user's preferred identity provider, by unspecified means, and redirects the user agent to the SSO service at the identity provider. The value of the SAML request parameter is the base 64 encoding of a deflated less than SAMLP, auth request greater than element. 3. Request the SSO service at the IDP, SAML 2.0 only. The user agent issues a GET request to the SSO service at the identity provider where the value of the SAML request parameter is taken from the URL query string at step 2. The SSO service processes the AUTHN request and performs a security check. If the user does not have a valid security context, the identity provider identifies the user, details omitted. 4. Respond with an XHTML form. The SSO service validates the request and responds with a document containing an XHTML form. The value of the SAML response parameter is the base 64 encoding of a less than SAMLP, response greater than element. 5. Request the assertion consumer service at the SP. The user agent issues a POST request to the assertion consumer service at the service provider. The value of the SAML response parameter is taken from the XHTML form at step 4. 6. Redirect to the target resource. The assertion consumer service processes the response, creates a security context at the service provider and redirects the user agent to the target resource. 7. Request the target resource at the SP again. the user agent requests the target resource at the service provider, again. 8. Respond with requested resource. Since a security context exists, the service provider returns the resource to the user agent. Note: in SAML 1.1, the flow begins with a request to the identity provider's inter-site transfers service at step 3.
The use of SOAP.
In the example flow above, all depicted exchanges are front-channel exchanges, that is, an HTTP user agent, browser, communicates with the SAML entity at each step. In particular, there are no back-channel exchanges or direct communications between the service provider and the identity provider. Front-channel exchanges lead to simple protocol flows where all messages are passed by value using a simple HTTP binding, GET or POST. Indeed, the flow outlined in the previous section is sometimes called the lightweight web browser SSO profile. Alternatively, for increased security or privacy, messages may be passed by reference. For example, an identity provider may supply a reference to a SAML assertion, called an artifact, instead of transmitting the assertion directly through the user agent. Subsequently, the service provider requests the actual assertion via a back channel. Such a back channel exchange is specified as a SOAP message exchange, SAML over SOAP over HTTP. In general, any SAML exchange over a secure back channel is conducted as a SOAP message exchange. On the back channel, SAML specifies the use of SOAP 1.1. The use of SOAP as a binding mechanism is optional, however. Any given SAML deployment will choose whatever bindings are appropriate.
SAML security.
The SAML specifications recommend, and in some cases mandate, a variety of security mechanisms. SSL 3.0 or TLS 1.0 for transport-level security, XML signature and XML encryption for message-level security. Requirements are often phrased in terms of mutual authentication, integrity, and confidentiality, leaving the choice of security mechanism to implementers and deployers.
Profiles of SAML.
Aside from the SAML web browser SSO profile, some important third-party profiles of SAML include OASIS Web Services Security, WSS, Technical Committee, OASIS WS Security SAML Token Profile, OASIS WS Security SAML Token Profile, Liberty Alliance, Liberty Identity Federation Framework, IDFF, Liberty Identity Web Services Framework, IDWSF, Liberty Identity Federation Framework, IDFF, Liberty Identity Web Services Framework, IDWSF, OASIS Extensible Access Control Markup Language, XACML, Technical Committee. SAML 2.0 Profile of XACML v2.0, SAML 2.0 Profile of XACML v2.0.
Security Assertion Markup Language.
Security Assertion Markup Language is an XML-based open standard data format for exchanging authentication and authorization data between parties, in particular, between an identity provider and a service provider. SAML is a product of the OASIS Security Services Technical Committee. SAML dates from 2001. The most recent update of SAML is from 2005. The single most important requirement that SAML addresses is web browser single sign-on, SSO. Single sign-on solutions are common at the intranet level, using cookies, for example, but extending these solutions beyond the intranet has been problematic and has led to the proliferation of non-interoperable proprietary technologies. Another more recent approach to addressing the browser SSO problem is the OpenID protocol. The SAML specification defines three roles: the principal, typically a user, the identity provider, IP, and the service provider, SP. In the use case addressed by SAML, the principal requests a service from the service provider. the service provider requests and obtains an identity assertion from the identity provider.
ML.
The Oasis Security Services Technical Committee, SSTC, which met for the first time in January 2001, was chartered to define an XML framework for exchanging authentication and authorization information. To this end, the following intellectual property was contributed to the SSTC during the first 2 months of that year. Security Services Markup Language, S2ML, from Nitigrity, XML from Securant, XML Trust Assertion Service Specification, XTAS, from VeriSign, Information Technology Markup Language, ITML, from JAN. SP may rely on and trust assertions from many independent IDPs. SAML does not specify the method of authentication at the identity provider. It may use a username and password, or other form of authentication, including multi-factor authentication. A directory service, which allows users to log in with a username and password, is a typical source of authentication tokens, for example passwords, at an identity provider. The popular Internet social networking services also provide identity services that in theory could be used to support SAML exchanges.
History of SAML.
On the basis of this assertion, the service provider can make an access control decision, in other words it can decide whether to perform some service for the connected principal. Before delivering the identity assertion to the SP, the IDP may request some information from the principal, such as a username and password, in order to authenticate the principal. SAML specifies the assertions between the three parties, in particular, the messages that assert identity that are passed from the IDP to the SP. In SAML, one identity provider may provide SAML assertions to many service providers. Similarly,